All right. Can you see my screen?
Yes. Yeah.
Cool. Well, I'm Sam Roundy. I own a company called TestStand. It is a side gig for me. And I'm an Eagle Scout. So we're going to be talking about property objects and TestStand. Feel free to ask any questions as we go here. And we'll dive right in here. So here's an overview. We're going to look at what property objects are, how we can convert existing objects to property objects, common API methods and properties, and then we'll look at property object files for a minute. And then I'll do a demo on recursing through property objects. So if you go to TestStand, and you go to the help, and on the index tab, you can type API. There is an inheritance right here that shows, I don't think they're following David's UML very well here, but this shows the inheritance, I guess, within TestStand. It's very, very flat, if you will. The property object sits on top, and basically everything inherits from it. There's a little bit of hierarchy going on, and this doesn't show everything. If you scroll down, there's a whole bunch of missing classes as well that aren't in there. And you can double click on any of these or just single click on any of these and look at the APIs. So you can look at all the properties and methods. We'll be talking about a lot of those today. So yeah, pretty straightforward. In TestStand, if you call a object, you just have to use the dot notation and use dot as property object is the easiest way to do it. In LabVIEW, there is a invoke node that you can just pass your object into and then get it as a property object out. You can also use the variant to data in LabVIEW if it doesn't exist. I think this was the old way of doing it back in the day. But once you convert it to a property object, then you can start using the property object API. So pretty straightforward. So these are some of the, I want to highlight, I do a lot of property object manipulation in TestStand almost daily. And I'm going to highlight some of the common ones that I deal with, such as, we'll start simple with like name and type and different things like that. And then we'll get a little more advanced as we move through them. But here's all of the methods and properties that are available for a property object. So the first one is the name, or before I dive into this though, I want to talk about lookup strings. If you're not familiar with lookup strings in TestStand, basically they are addresses that point to a certain property object within a property object. So the API uses lookup strings a lot, and these are all relative to the object that you're performing the operation on. So, and if you want to do the actual operation on the object you're looking at, you just use empty quotes. So, for instance, get val boolean. I show 3 different ways that you can do that. If you had a container in locals, there's 3 different ways that you could get that based on where you are in your iteration or recursion or whatever of looking through stuff. So that's key right there. Understanding, if you understand these lookup strings, the methods are very easy to use in TestStand because half the battle is understanding these lookup strings. So pretty straightforward. The first simple object is name. That just returns the name of the property object. Here's an example. If I have file globals and I want to get the third, element, these are 0-based index. So if I want to get the third item in my file globals, or the name of the third item in my file globals, I can do this. And in this case, if my file globals look like this, this expression right here would return test reference, because that's the name of the third element, so, or object. The next one, which I use a ton, especially for recursion, is the type. So in TestStand, if you're looking at a property object and you don't know what it is, you just can use the type and then the value type. The value type is basically an enum that will tell you kind of what category it is, and then you can decide what to do based on that category. So if we hop back over to here and we look at the type right here, it basically returns a property object type, which is a different class essentially. And then this value type right here is what I'm looking at. And so that means that I can case off of that. And we'll see that when I do my recursion demo, that you can case off that and then you can iterate through these hierarchies of property objects. So any questions before I move on? Nope, we're good.
I think we're following so far. I'm sure.
All right. Good. The elements and the sub-properties, they're completely different. Most people have to learn this the hard way. Get num elements, get nth sub-property elements, and get property object elements are all related to arrays, property objects that are arrays. So you have to look at the type first before you use these, or unless you already know it's an array, then you can just use these. And then the get num subproperties, the get nth subproperty, and the get subproperties are dealing with containers. It's kind of confusing when you're first looking at them, because a lot of times people will say, well, I'm calling get num elements, and this is an element in my property object. But whenever you see the word element, that is dealing with an array. So hopefully that makes sense. And we'll see that also. And then these methods right here are probably the most commonly used API calls on property objects, in my opinion, or at least I use them the most. Get val and set val, and then there's a whole bunch of different types that you can use these with. iDispatch and what's the other one? iInterface or interface. Those are used for references. So they kind of behave a little differently. One is kind of in the same thread or something like that. Anyways, you can use those for references. The trick with these properties, or with these methods, is the options. The options are key. There's a whole bunch of options that you can pass, and you can actually, let me pop over to TestStand here. If I go to my property object and I go into any one of these, so let's say get val boolean, and I go to my property options right here, you can see all of the property options available. And you can actually add these together. So if you want to use this one and this one and this one, you just take these numbers, add them together, and then use that value. So it's basically each one's like a flag, and you're just putting all the flags in there essentially, because they each use a different bit. So once you understand that, the most common one that I use is insert if missing. So if I hop over to TestStand, I can actually, I got basically an empty sequence here. We can throw a create local, throw a step down, throw a statement down. Let's say that I want to do locals dot set val number. I can call it foo. So 0x1 will inject it into locals if it doesn't exist. And then let's say I just want to assign it to a random value between 0 and 100. And then I can run that step. Now, there's a key here, though, because what you're going to see is it will run it. And when I step over, you'll see that it injected the local variable. But when I continue, the local variable is not there. So if you want to do it, if you want to actually inject it into the file, you have to do sequence file dot data dot locals. I believe. No. Anyways, there's a way. I don't want to spend time on that right now.
Sequence level.
What's that?
I guess you're missing the sequence level. Sequence file, sequence, and locals.
Yeah, there's a way to do it. It's through the data. But basically, then you can inject it back into the file if you grab the disk copy of the sequence file, not the runtime copy of the sequence file. So the point is you can inject these as you're going so that you don't get errors when you try to set them and they don't exist. So I use that all the time. The other one, you can remove the element if you want to. I don't use that very often, but that is an option. So yeah, you can read more about those in the help. They're very handy. Any questions on these methods before I move on?
The options, you said you could add them together. Can you specify them individually as well?
Yeah, if you're specifying them individually, you would just use the number that's right here.
But if you wanted to use two options, can you specify what, two options together? Or you have to.
You would take this hex number, add it to this hex number, and that's the hex number you would use.
Right, so you have to rely on good commenting if you're using a complex option to tell someone else reading it what the hell you've used.
Yes, that's correct.
You can't put in the number itself. I mean, and have an add operation, and
you can do that too.
Use the name as well. It will be.
Yeah, and you can use these names here. They are.
Oh, okay.
They're reserved words or keywords in TestStand, so you can use those.
If you start typing prop option and control space, you will see the list of all the available property options as well.
Yeah. Insert if missing, is that what it's called? Yeah. So it'll use that too. And then like some of you mentioned, you can add like that and then do the next one or whatever. So that can self comment, or you can just throw a comment out here. Yeah, any other questions? One of the things I always tell people is you can tell when TestStand users have arrived is because they understand property objects. Well, the first thing they have to understand is data types and then property objects. But yeah, that's when I can tell people are really good with TestStand is when they understand property objects. So write and read are really handy. Basically, you can take any property object and just chuck it into a file and just basically dump it into a file for later use. So the other day I had a question from one of my colleagues and they wanted to, let's create a new sequence here and let's insert. Basically, they wanted to take all the locals and the file globals and spit them out to a file if there was ever a failure. So if we do like sequence file post step failure, And we throw that down, and then we can, let's force a failure in here so that we can trigger that. So that'll trigger a failure, and then this will get called. And then from here, what we could do is we can just basically say caller.locals. Caller will give me the sequence context of the caller, which in this case will be main sequence. Locals.write. And then you can feed it a path, and I will give it, we'll just throw it in a temp file. Here. Oh, and by the way, if you don't know, you can use that @ symbol at the beginning of a string, and that will ignore these slashes as escape characters. So you don't have to go through and put 2 slashes for every path, which is very annoying. So this would be, if you're not going to use the name of this string object name, is if you want to give it a different name, you can, but if I leave it empty quotes, it'll just use locals. And then these read write options are basically, if you want to erase everything, or if you want to rewrite the whole file, or if you just want to add what changed, or if you just want to put the values only, you can use all of these. And the same thing applies here, where you can mix and match and add and all of that fun stuff. So I'm just gonna do 0xf because I want all of them. I think they're all good, just for this case. So let's throw some local, not in there. Let's throw some locals in here. We'll do an array of NI limit measurements, just because I like that one because it's a big data type. So it'll give us a nice chunky file. So then I just run this. Oh wait, we forgot something. Before I do that, I'm going to get an error if I do this. We need to give it a file name. There we go. So if we go back to that location, we should have this local file, and we basically dumped all of those locals into here. So then if we need to go through and analyze it, at least we have something we can look at. Any questions on that? All right, I think everyone went home. So those are handy. The other reason that you can use the other thing you can use these for is you can actually write data out to a file and then tweak it and then read it back in. So if you want to change values, then you can have a whole bunch of property object files sitting out there, and you can read those back in and assign them to the local variable, so that you can get back to a certain state if you wanted to. So that's pretty handy too. Be careful with that though, because if you ever change the type, then they become, incompatible unless you know what you're doing. It's very crazy. So types have to match. XML is kind of the same idea, and I'm not going to do a demo on this one, but basically you can basically get XML or set XML. It's kind of the same thing with read and write, but it gives you this XML format like this right here, this example down here. I've used this for storing steps in a database, because then they are not part of a file, essentially. I don't have to have a file to have the step, and I can push them all into the database, and then I can suck those in and inject them into my sequence as it's executing. And then I don't have to have a sequence file laying around with all these steps, and they're up in this database, which is kind of nice. I can just pull them down whatever I want. So I've used them for that before. But it's good to know about that and that exists. Numeric format is one that's very key that I use all the time, especially for doing plugins. In plugins, a lot of times you'll recurse through the result list to get all the information and then eject it into Excel or whatever format you're putting that in. And you want the numeric values to show whatever the initial developer set the formatted value to. And so in this case, if you were to put a hex or you want a trailing zeros or whatever, this get formatted value will use whatever that numeric format was for that number, essentially. And it uses the cprintf format. So that's your format string, essentially. You can feed it a format string and then it will reformat it to whatever whatever you feed it as well. So questions on that?
That's clear.
Yeah, it's very handy. Attributes, for those of you that aren't familiar with how attributes work in general, basically think of it like a horse riding a horse and a horse on top of that horse. Basically, it's a container that you can add onto any property object, and then it has a whole bunch more. You can put whatever you want in that container, essentially. Every property object has attributes in TestStand, and you can get those by calling step.asPropertyObject.attributes if you're doing it on a step. So if I'm in TestStand, and let's say that I have let's create a new one here, a multi-numeric limit step, and I don't want to create a bunch of locals, I can go to the properties here, and I can click on this little attribute symbol, and I can add some, I don't know, we'll call this high limit. And then we'll add one that's like a low limit. Set this to, 100 and set this to like 50 or something, I don't know. That way, whenever I have one of these, I can just call that out, step.asPropertyObject.attributes.highLimit. Or sorry, this one's low. That won't be bad. And same here. So the advantage of doing that is that now I can write easier tooling around manipulating steps. So if I put everything that I want to change about the step in the attributes, then my tool only has to recurse through the attributes and inject those or update those or do whatever I want with the attributes. And so I can add a bunch of, if this was a LabVIEW call or a sequence call or something like that, I could do that with the parameters too, and just assign those to the attributes. And then in my tooling or whatever I display to the end user or whatever, I can only grab the attributes, and that's what the developer intended the end user to see. I don't know if that makes sense, but I use that sometimes. So, questions on that? Awesome. How are we doing on time? We're only 12 minutes over. So then there's this other layer called property object files, and they're basically an in-between. They're in between a property object and a file, because all of the files in TestStand needed kind of this common set of properties and methods associated with them. And so I'm just going to look at a couple of these. The path is the obvious one. The other one that you'll want to use quite frequently is this property object file.displayName. That's very handy because if you're in TestStand and you want to, let's just throw down a sequence here, and we'll throw down like a message box. What I call it, as property object file you can then just get the name of the sequence file really easily, because otherwise you have to parse through that path to try and get that out of there. And so this is handy for that reason. It's kind of like the strip path in LabVIEW. Yeah, so those are useful. Change count is one of those things that's hard to understand at first when you first hear about it. But if you're ever changing a file through a tool or otherwise, you should always call inc change count, because inside of every property object file in TestStand, there's this counter, and it keeps track of all the changes. And this is so it can synchronize with other processes and other applications and things like that. And so you always want to make sure that you inc change count whenever you edit a file through the API. So any questions on that? Nope. All right. So write file is pretty straightforward. Save file if modified. And then if you're actually dealing with a sequence file, just use the save function for that. That's the easiest. But yeah. Oh, and you can use this write file, and you can feed it a format. So then you can save it as a different version of TestStand if you want. So if you have a sequence file and you want 10 different other developers to have it, but all of them are using different versions of TestStand, you could iterate on it, writing it to all of these versions, and then just give them the version they need. So, yeah. All right. Any questions before I hop in the demo? No. Okay, so I wrote a tool called Inspect PO, because sometimes I like to look at property objects and see like what everything is. And so if I run that on that message pop-up step, you'll see that I get all of this stuff. So then I can look at all the property objects inside of anything that I'm standing on, really, in TestStand, because this is very generic. So if I want to stand on, I don't know, where's that one with all that local one right here? Okay, so if I want to look at that, I could do that, and it will show me all the measurements, blah blah blah. So all the array elements. There are a few little issues with it, but it works pretty well. So if we look at that sequence, here's what's happening. In this step, I'm getting the initial selected property object, and it's kind of tricky because you can either get the initial property object or the initial steps or the initial sequences. And so I'm really, what this expression is doing is determining what they're standing on, whether they're standing on a property object or like a local or a file global, or whether they're standing on a step, or whether they're standing on a sequence or a sequence file or anything like that. So this is all this is doing is building an array of property objects that the user has selected. And then I iterate over that array, and I recurse and get all of the property objects, and I put them in this data right here. So if I were to insert an element, you would see that this has a name. So it's the name of the property object, the depth, meaning how deep it is down the property object tree, and then I get the value, and I get the type name, and then just I have another thing here for other if there's anything else that I want to grab and chuck in there. So if we were to look at this VI, basically I pass in my property object, I look at the type, and I get that value type. This is what we looked at earlier, and that's really what I'm keying off is that value type. The wire's kind of hard to see here, but I put this in here so that I can refer to it. But this is straight from the TestStand help, and it shows me, okay, 6 is an array. So if I hit an array, then I want to get the number of elements, and if they're less than 0, I just want to put empty array in my value and move on. If there's more than more elements than 0, then I will iterate through those or go through those and get each one, and then I have to recurse back down through that property object. So I don't know if that makes sense. There's strings, pretty straightforward. I just get get val string, the enum, same thing, Boolean, numeric. This is where that get formatted value comes in handy, because then I can get the format that they have set that variable to. The reference, I didn't really know what to do, and you can get more sophisticated with this if you want to. So I just threw a reference on the value and just closed the object. And then the container and the name type, and then if just in any default case, I look at it, I get the number of subproperties. If there's not any, then I just get the XML and put it in the value. Otherwise, I recurse down through the property object to get all of the children, essentially. So pretty straightforward, pretty simple. It works. You can adapt this to however you want to do it. Are there any questions on that?
Does it also get all the attributes for the steps as well?
Yeah, I don't have that in this version. I have created versions where you would get the attributes. So basically what you would have to do is have another thing out to the side here, or before probably, that you would get the attributes and then recurse down through those. And so it's the same thing, right? But yeah,
Okay.
that's an option too. So
is it also possible to get this property value type names somehow from API? So instead of using numbers in case, we could create programmatically enum, for instance, or string.
So it's not an enum, it's actually a ring. So if you create a constant, it will give you this, and you can change this to an enum. So if I select it and I go to enum constant, I can replace it with an enum, and now it's an enum. And I could use that, but I'm using what comes out of here, and I guess I could typecast it and then do that. So yeah, there's probably a way to do that, but I didn't take the time to do that. So
okay,
I don't know if that makes sense. But the problem is, out of here, it's a ring, so it won't give you the case structure, won't give you the names. But if I were to create this enum and then typecast it to that, then I could probably use that. So, yeah. Great questions. Any other questions?
So there's a question on the chat
Okay,
window.
I can't read that. Hold on. How do I look at those comments in here while I'm presenting?
Well, don't worry, I can read. Well, I think it's just a question. It's just a remark, not a question.
Oh, here we go. Okay, I got it. So okay. Thank you. Good comment. All right. Any other questions?
Nope.
Nope. Okay. Once I do that, I just pass that data type into a simple VI that just displays it on the screen. So if I want to look at, let's say, this sequence file, I can just do that, and it will do the sequence. Oh no, it grabbed the step. That means something's highlighted on the step. So it's kind of tricky because you got to watch where you're standing. So this gave me the sequence file. You can see there's the change count that I was talking about earlier. I've changed this 9 times since I last saved it. There's the path, and here's all the data. So yeah. Anyways, it comes in handy when I'm trying to figure things out sometimes. So That's basically the presentation, or at least the shortened version of it. So any questions before we wrap up? Awesome.
No.
Thank you, everyone.
That was very good. Thank you very much.
Can I still have a question?
Fire away.
Yeah,
So-
excuse me. It's just about property loader and or versus regex
Yeah,
or write
property loader
property.
cannot export or dynamically or programmatically or whatever. It you have to use the import export tool. But the format of the read, write, and the get set XML is not the same as the property loader. So yeah.
Agree. Okay, thank you.
Sam, so question, could you elaborate about this get set dispatch or dispatcher? What is it for?
So you're talking about iDispatch?
Yeah.
Yeah, so if you look in here, there's two that deal with objects. There's the iDispatch, which is a pointer to the value of the property. So this will give you a pointer basically, and it's used for ActiveX stuff a lot. So you can read through this help here, and then if you go look at the the interface, it's also used for ActiveX. It's also a pointer to the value. And I'm going to be completely honest with you here. I never really know when to use one or the other. I tend to lean towards the val interface if I ever do need it. I don't know why. It just seems to be better for me. But if you go read these remarks, it'll probably tell you why they're different. But yeah, that's their purpose, is for ActiveX objects and other objects like that. So.
Okay. Thank you.
Yeah. Cool. Thank you.